All right, so for geometry, we're doing 9-2. We're talking about surface area of prisms and cylinders today. And then next week, we'll get into surface area of pyramids and cones. All right, so first of all, surface area is the total number of square units needed to completely cover the figure. Okay, so we actually did this yesterday when we had the net. Remember the last question that we had the net laid out there and it said find the area, the total area of all the faces? That's surface area. Okay, so it's like if we wanted to, like if you were going to manufacture something, like Pringles, right? Like they come in that cylinder can. Well, you have to create the design to go all the way around the lateral surface of that can. Now, so that's actually lateral surface, not surface area, because surface area would include the lid and the bottom. But we don't put a lid on the like that part, right? Okay, or we don't put a label, pardon me, on that part. We just put a label on the lateral surface, or like on a cereal box, right? We cover a cereal box, the top and the bottom, everything, with something. There might be a barcode, there might be the label, there might be the calorie information, all that stuff. Okay, but the total surface area is everything. We're going to completely cover the figure like a cereal box does. So this formula for surface area is S. So S stands for surface area. L plus 2B. Okay, and it says when S equals the surface area, L is our lateral surface area, and B is the area of each base. All right, so let's look at this for a second. The lateral surface area, if we look at the diagram, is just the just the sides that you see. It's not the bases. That's why that's labeled L in there. So most of the time when we're finding surface area, it's easiest to think about it as a net, to open up the shape to see its lateral surface. So we can find the area of that, and then B is the area of each base. Okay, and so like this base is a rectangle. What's the formula for the area of a rectangle? Area of a rectangle, length times width, or we might say base times height. So that's what you would do, is you would multiply those together, just like we did yesterday. All right, then we don't need this base edge. That was from yesterday. I didn't get it deleted. I apologize. So you can cross that one off. Woohoo! All right, so we do have some theorems here. The lateral surface area of a right prism. Okay, so we're looking at a right prism is the products of its height and the perimeter of its base. So the formula is right there. L equals P times H, where L is the lateral surface area, H is the height of the prism, and P is the perimeter of the base. Okay, so when it's talking about this, we're just looking for the lateral surface area. Okay, so the perimeter of the base would be this, right? That's our P. And it says it's perimeter times the height. Well, if we look at the net, it's the length times the height, or the base times the height of that rectangle. Does that make sense? Yep. On how we're looking at it? Okay, but if we want to find it, we can say, oh, well, we'll just find the perimeter of the base and then multiply it times the height all the way up. It is this very similar for the surface area, the lateral surface area of a right circular cylinder. Why can't there be any left? It's right because we want it, the height has to form a right angle with the base. But it's a circle. Right, but it's a right circular. So we don't want a cylinder that's like an oval shape, like this. Does that make sense? Okay, so that's what we're talking about. So we want that right circular, like a can of soup or a soda bottle, something like that. Or it has to form a right angle. Whoops, too many. Okay, so with that one, the formula is very similar, except L equals CH. What's the C stand for? Circumference. Okay, so it's the same thing. So if we open up the net, again, if we open up the net, we get a rectangle shape. So we've got the length times the width of this rectangle. If we leave it as a round part, we want the circumference of the base times the height. Okay, earlier we wanted the perimeter times the height. Now we want the circumference times the height. We good so far? This is lateral surface area. Say that.
Lateral surface area.
I said say it. I said say it.
What?
Lateral surface area.
Longitude surface perimeter. Lateral surface area.
Step on your nice kicks. Okay, so then the last theorem that we have down here is the surface area of a cylinder or a prism. So now we're changing to surface area, not lateral. This is like total surface area. Bases included. Okay? Is S equals L plus 2B. So in order to find the surface area, we have to find the lateral surface area, and then we also have to find the area of our bases. Now, here's the thing. It's a little bit time consuming because you have to think through it, but ultimately it's at the same time really super easy. Like we have to find the lateral surface area, and no matter what shape it is, you know all the formulas to find the area. If it's a rectangle, if it's a triangle, if it's a trapezoid, does not matter. We know, yep, we know how to find the area of any of those polygons, and we have to apply them here when we're doing this. Any non-gon, n-gon, we have a formula for to find the area. Remember, it's the apothem times A? Or is it half the apothem times A, I think, actually? Okay, so example 1, we want to find the surface area of the right triangular prism. Sorry, I have my paper keeps sliding. All right, so a few things. First of all, what's the formula for surface area?
S equals L plus 2B.
Okay. How do I find, what's the formula for L?
L equals CH. No.
Not CH, because we don't have a circle. What was it?
BH.
Not BH.
BH.
P. Okay, good. pH, like, what's the acidity and alkalinity of the surface? Okay, also, we also have this capital B. What's the formula for that capital B here?
B equals 8 times 7.
Okay, not quite.
Yes.
Because B, our base, is what shape?
Oh, triangle.
It's a triangle. So what's the formula for the area of a triangle?
B equals 1/2 base times height.
Lowercase b. Good. So base times height. Okay, capital B is the area of the base. Lowercase b is the base of the triangle. Okay, so some of those things, and like we have a lowercase h, like some of those things do matter. But these are all the formulas you're going to need to solve or to use to find the surface area.
25.
All right, so where do we want to start? The surface area or the lateral or the base?
The lateral.
The lateral.
L equals 25 times 20, which is...
Okay, time out. So he said L equals 25 times 20. Where did these numbers come from? So I'm assuming 25 is your P. So how'd you get your P? The perimeter. Okay. Okay, good. So the 8 plus the 7 plus the 10 is the perimeter of our triangle. Good. And then the height is right here, right? 20 equals height. Perfect. So our L equals...
Lucas, I'm giving you a chance. Isn't it 500?
It is 500. Okay, so our lateral surface area is 500. Okay, so now let's find our base area. It's 1/2.
8 times 7.
8 is... Okay, so here's the thing.
The other one is the other one is
You don't know if this is a right triangle.
So it'd be 7.
Would not be 7. You need to look for where there is a right angle in the diagram to know what your height is. 5.6, right? Okay, so this is not a right triangle, but it does give you the dashed line right here with the right angle. That means that this 5.6 is your height of your triangle. So it's going to be... Okay, time out. No, your height and your base are perpendicular to each other. So if your height, it'd be 10.
5 times 5.6.
Okay, so it's going to be 10 times 5.6, okay? Because our base and our height are always perpendicular. So those are the two numbers we have to use. All right, so that does equal 5 times 5.6.
No, let's just do half of 56.
I would do that too. So 10 times 5.6 is 56. Half of 56 is?
Lucas? 23? 26.3. Oh.
28.
What?
It's 28.
56.
Half of 50 is 25. Half of 6 is 3.
Oh, there it is.
25 plus 3 is 28.
I had half of 3 for some reason.
Okay, you're okay. All right, so we've done lateral surface area. We've found the area of the base. Now we're ready to find our actual surface area. So S is going to equal our lateral surface area, which was what? 500, plus 2 times the area of our base, which was 28. So this is going to be 500 plus 56. So our surface area equals 556 centimeters squared.
We didn't even have to half the base.
It's true, you wouldn't even have to half the base in this case, but we need to find the area of the base. Are there questions? Because we kind of flew through that. Okay. Then in example 2, we want to find the surface area of the circular cylinder. All right. So let's again list out the formulas we're going to do. So surface area is L plus 2B. How do I find the L then?
L equals CH.
Okay, in a circular, it's going to be CH. How do I find my base here? Since my base is a circle. How do I find the area of a circle? Not 2 pi r. That'd be the circumference.
That's what you're trying to find.
I want the base, the area of the base. We do want circumference. So up here, C equals 2 pi r. But capital B means I want the area of the base. In this case, the base is a circle. What's the formula for the area of a circle? Do you have your quick reference guide? Here, let me stand here and you can look at it. What's the formula for the area of a circle?
1 or pi d equals 2 pi r.
No.
Yes.
No. That's the perimeter.
Be this one. Pi
Yep.
r squared.
Pi r
That's
squared.
what I said.
No, you didn't. You said 2 pi r.
No.
Okay, so the area of the base here, since it's a circle, is going to be pi times the radius squared. So again, the formula for the base is going to change depending on the shape that you have.
So would it be 12 pi? Would you put 6?
We would, well,
Wait,
but
no,
it'd be 36 pi.
Mm-hmm.
Hold on.
6 is the radius.
Yeah, So you want to start with that one? Because you said 6 is the radius, so this is going to be pi times 6 squared. So the base is 36 pi. Okay. So we got that one. So are we ready for, do you want to do the,
So then the next one would be 2 pi 6.
yeah, so for our circumference, right, because we need it before we can actually solve for our lateral. So it's 2 pi times 6, which is, you said it, I thought,
2 pi
12
6.
pi
is, okay, is the same thing as 12 pi for our circumference. Good.
times the height.
Okay, so now for our lateral, right, we're going to take the circumference, so the 12 pi, and multiply it by the height of our cylinder. What's the height of our cylinder? 9. Right, there's our height. So our lateral surface area is
108 pi.
108 pi. Okay. So there's a lot of intermediate answers. Hopefully you see that.
So then it'd be
So then our surface area is going to equal
108
108
plus
pi.
pi plus 2 times 36 pi.
You got it. So that's going to equal 108 pi plus 72 pi.
So 172 pi?
108 plus 72.
So 180 pi.
180. So 180 pi. Or if you put it in the calculator to actually get an answer, it's going to be about 565 feet squared is the surface area.
Would it be pi squared or no?
It wouldn't be pi squared. It would be 180 pi feet squared. Sorry. Is that what you were getting at? Yeah. We'd have to put the feet in there and then square the feet. Okay. Perfect. All right. So we have one more example on the back to go through. And it's a word problem. It's okay. So find the radius of a soup can that is 10 centimeters tall if its paper label overlaps itself by 1 centimeter and has a total area of 242.5 centimeters squared. All right, so if we think of this, we want the radius of a soup can. Well,
So would it be 200? Would you kind of do like 242.5 centimeters squared equals?
we are, because the 242 is going to be the area, and it's a total, right? Has a total area, but what says the label, right? Has a total area.
Then would it be like
Oh, I don't need the centimeters.
Divide by 11. Or no. Subtract 11 and then divide by 2 to find the base.
Okay.
Wouldn't you?
Not quite.
Why?
So you need to think about, like, what is this? Like, what's the formula for what you have? Like, 242.5 equals, yeah, but what should be over there? Like, because the formulas can be so complex. So what is 242.5?
L plus 2.
No, it's lateral.
This is the lateral surface area, because yes, we're talking about the radius of the soup can, but they're giving us information about the label that covers the soup can. So it only goes around the lateral surface.
So 11.
Okay?
It would be 11 because it's 1 centimeter longer.
No, it's not 11. It says that the soup can is 10 centimeters tall. Okay, that's terrible. It's 10 centimeters tall, and the paper overlaps itself by 1 centimeter. The paper goes around the can. So if I were to think about this, like if I were to look at the paper label is a rectangle that's 10 centimeters tall. And it covers the soup can until here. Yeah. And then there's one more. Like this distance over here is 1 centimeter where it covers. Because they have to glue it, right? They put a strip of glue on it and it has to cover so it'll stay on the can. Because it's not printed on the can. Some things like print the label, right? A soup can overlaps and is glued. They have to have that 1 centimeter of space to do that. So, yes,
that would be
this
the
is
h.
the lateral. Lateral is the circumference times the height. So we need 242.5 equals the circumference
X plus 1.
plus 1. Good. Right? Because our circumference would actually end right here. That would be the circumference of the can.
And
Plus
then
1.
times
Then times the height, or 10 in this case. Perfect! But do you see how knowing like this formula, we knew exactly what to put in. Once we have the equation written, like you guys can solve it with no problem. It's just getting that equation figured out.
Is that it?
Well, now we want to solve. Yeah, that's it. So how do we solve it?
24.25
Okay, so time out. We divided by 10. We got 24.25 equals C plus 1, I heard. Okay. Subtract the 1. Thank you. So 23.25 equals the circumference. Okay. That's helpful. But I don't want circumference. I want radius.
Equals C.
Yeah, 23.25 equals C, but C stands for circumference. It's asking me for the radius.
Then would you divide
pi r squared.
Okay, so what's the formula for circumference?
Pi r squared.
Pi r squared is not
No,
circumference.
it's just pi squared.
2 pi r.
2 pi r, okay? And we know the circumference is 23.25.
Divided by 2.
Well, we could go ahead and divide by 2 pi even. Because then those would cancel and we would have our radius is equal to. You're gonna need a calculator.
I can't find pi.
Just
You'd use 3.14 if you want. 6.28 with 2 times pi.
3.7 approximately.
Okay, so we'll change this to some wavy lines. 3.7
That's it.
units, sorry, is what I was going for.
Centimeters.
Centimeters. Squared? For
No,
radius?
just centimeters.
Just centimeters. Okay, good. That's what I was kind of hoping for. Was that mistake to be made because we're looking at just the radius now. Yeah. So again, like this is part of like what I think is sometimes the cooler math because it's like, okay, I solved this formula, but I'm like, okay, I'm still not there. How do I piece it together with another formula?
18 formulas before you get what you want.
Right. But this is where like when we did proofs at the beginning of the year, I'm like, okay, well, we proved this. Well, now where can I go from there? Okay, well, then you have to think there and look and process and do something else. It's kind of the same thing. Like it's kind of like its own proof. You can't get directly to the
It
radius.
almost seems like this proof is downgrading while the other proof is upgrading. Somewhat.
Yeah. I could see that. Because yeah, but like it's like recognizing, well, I can't get directly to my radius, but I can find my circumference. From my circumference, I can find my radius. So yeah, but it's a proof in its own way. So hopefully doing proofs earlier has paid off in solving problems like this.
Yeah, earlier, not now.
We haven't been doing proofs for a while.
And I'm trying to hint you that we shouldn't do anymore.